Hello and welcome to this session. Today I'm going to discuss about decision tree and random forest classifier. In the introduction part, we will talk about decision tree and how this algorithm works. The idea was to represent data as a tree where each internal node denotes a test on an attribute, basically a condition. Each branch represents an outcome of the test, and each leaf node, you see the leaf node is terminal node, holds a class label. Decision trees are the foundation for many classical machine learning algorithms like random forest, bagging, and boosted decision tree. Decision trees were posted by Leo, a static man at University of California, Berkeley. Decision trees are the foundation for many classical machine learning, as I mentioned, like random forests. Also, decision trees are now widely used in many applications for predictive modeling, including both classification and regression. Here is an image explaining the basic structure of decision tree. Every tree has a root node. You can look at this one. This is the root node where the inputs are passed through. This root node is further divided into set of decision nodes. You see the splitting. Set of decision nodes where result and observation are conditionally based. The process of dividing a single node into multiple nodes is called splitting. You see here? The process of dividing a single node into multiple nodes. If a node doesn't split into further nodes, then it's called a leaf node or terminal node. You can see here, B and C is a terminal node. A subsection of decision tree is called a branch or subtree. For example, in the box, in the image below, here is subtree. There is also another concept that is quite possible to splitting, or it is opposite to splitting. If there are ever decision rule which can be eliminated, we cut them from the tree. This process is known as pruning. Pruning is useful for minimizing the complexity of algorithms. In terms of decision tree algorithm terminology, we would like to talk about some specific keywords. We call root node. It represents the entire population or sample. This further gets divided into two or more homogeneous sets, splitting. It is a process of dividing a node into two or more subnodes. We have the orange color here, decision node. When a subnode is split into further subnodes, then it's called a decision node. Leaf or terminal nodes. Nodes that do not split are called leaf or terminal nodes. Pruning. When we remove subnodes of a decision node, this process is called pruning. It is the opposite process of splitting. Branch or subtree. A subsection of an entire tree is called a branch or subtree. Parent and child node. A node which is divided into Subnodes is called the parent node of subnodes, where subnodes are the children of the parent node. Let's have a look how does decision tree work. We have the decision tree algorithm intuition. The decision tree algorithm is one of the most frequently and widely used supervised machine learning algorithms that can be used for both classification and regression tasks. The intuition behind the decision tree algorithm is very simple to understand. For each attribute in the dataset, the decision tree algorithm forms a node. The most important attribute is placed at the root or node. For evaluating the task in hand, we start at the root node and we work our way down the tree by following the corresponding node that meet our condition or decision. This process continues until a leaf node is reached. It contains the prediction, the outcome of the decision tree. Let's have a look to criteria to split the data. The objective of decision tree is to split the data in such a way that at the end we have different groups of data which has more similarity and less randomness or impurity. In order to achieve this, every split in decision tree must reduce the randomness. Decision tree users or decision tree uses entropy or Gini selection criteria to split the data. We are going to use scikit-learn library to test classification and regression. Entropy or Gini are selection criteria for classifier versus MSE, Friedman MSE, and MAE are selection criteria for regressor. Entropy measures the impurity in the given dataset. In physics and mathematics, entropy is referred to as the randomness or uncertainty of a random variable x. In order to find the best measure which will reduce the randomness after a split, we can compare the randomness before and after the split for every feature. In the end, we choose the feature which will provide the highest reduction in randomness. Formally, randomness in data is known as entropy, and difference between the entropy before and after split is known as information gain or IG. Since in case of decision tree, we may have multiple branches, information gain formula can be written as here. Gini. Another attribute selection measure that CART, categorical and regression trees, uses in the Gini index. It uses the Gini method to create split points. Gini index can be represented with the following formula. So, in case of Gini, decision tree will split the data using the feature that provides the highest Gini gain. Gini impurity is computationally faster as it doesn't require calculating logarithmic function. Thought, in reality, neither metrics result in a more accurate read than the other. Here we look at some advantages and disadvantages of decision tree. The advantage of decision tree is simple to understand and to interpret. Trees can be visualized. Another advantage is it requires little data preparation. Other techniques often require data normalization. Dummy variables need to be created and blank value to be removed. Note, however, that this module does not support missing values. Decision tree able to handle both numerical and categorical data and multiple output problems. Decision tree uses a white box model. Results are easy to interpret. Decision tree also is possible to validate a model using a statistical test that makes it possible to account for a reliability of the model. On the other hand, the disadvantages of decision tree. Decision tree learners can create over complex trees that do not generalize the data well. This is called overfitting. Mechanisms such as pruning, getting a minimum number of samples required at a leaf node, or setting the maximum depth of the tree are necessary to avoid this problem. Decision tree can be unstable because a small variation in the data might result in a completely different tree being generated. This problem is mitigated by using decision tree within an ensemble. Decision tree learners create bias tree if some class dominate. It is therefore recommended to balance the dataset prior to filling with the decision tree. After you learn the theoretical part of decision tree classifier, now it's time to implement decision tree classifier in Python. The first and foremost step in building our decision tree model is to import the necessary packages and modules. We import the decision tree classifier class. You can see here, decision tree classifier class from the scikit-learn package. This is an inbuilt class where the entire decision tree algorithm is coded. In this program, we shall use the iris. We use the iris dataset that can be imported from scikit-learn.dataset. They already have inside. The plot package or py.plus package is used for visualizing the decision tree. Here, py.plus package is used for visualizing the decision tree. So, step 1, import py.plus. Step 2, import decision tree classifier class. And step 3, import the dataset. Now it's time to export the data. Next, we make our data ready by loading it from the dataset package using the load iris. Yes, exactly. You know that in the previous one we have to import accuracy score, and we have to import also training test split, means that you have divided between training and test. This step importing and exploring the data. First, we use this data. In the previous lecture, we assign the data to this iris app variable. This iris variable has two keys. One is a data key where all the inputs are present, namely sepal length, sepal width, petal length, and petal width. In the target key, we have the flower type, which has the value iris setosa, iris versicolor, and iris virginica. This is the target key that we have. We load these in the feature and target variable respectively. Splitting the data set into the training set and testing set. Here we load the decision tree classifier, and also we divided the training and testing data set. For the test size we put 20% and the training size is 80%. When we print it, you will see how it goes. Now it's time to focus on building the decision tree model. Here we load the decision tree classifier in a variable name model, which was imported earlier from the scikit-learn package. Here you see, in this scikit-learn package you have decision tree classifier. Now it's time to build the model. You build it, put in decision tree variable, decision tree dot feed onto X train and Y train, put in the model. There is some error here that we have to take care. Why? Because in previous one we didn't run the X train and Y train, X test and Y test. Now it's time to run it. After you put X train, when you have the length is that 120 sample, X test 30 sample, means that 80% training, 20% testing. Now you run again. Yes, this is already done. The next step is to evaluate the model. We use the test data that you can see in this call. You remember the test data to see the prediction. So after you build a decision tree model, it's time to predict the test set result. In most application or most of the high rank papers, they need the prediction in test size. Now it's time to run it, and the prediction score, accuracy score is 1. So the next step is dot data for the prediction. What is it? In this step, we export our train model in dot format, DOT format, a graphical description language, DOT. To achieve that, we use the tree class that can be imported from the scikit-learn package. On top of that, we use the export graphic viz. You see that? Export graphic viz method with the decision tree features and the target variable as the parameter. Let's run and see what will be happen. After we run the dot format or dot data for the prediction, everything is clear. Now it's time to draw it, drawing the graph. In the last step, we visualize the decision tree using an image class that is to be imported from the ipython.display package. Here I will try to run it and we have some error. Then this error means that you have to pipe the graph viz. I can show you in next slide. After you get an error, such kind of error, we have to import the pipe install graph viz, and after this in order to visualize and use py.plus package, you have to go to this website graphicviz.org, and if you use the Windows, you just simply install this graphic viz exe installer. After downloading the graphic viz setup, you have to do the license agreement. In section install option, please choose add graphic viz to the system pass for all the user. Otherwise, your visualization graph will be not shown properly. In previous slide, in section Gini, we mentioned that another attribute selection measure that cart uses is the Gini index. It uses the Gini method to create split points. Gini index can be represented by this formula. The formula mentioned as below. The Gini coefficient measures the inequality among value of a frequency distribution. In the case of Gini, decision tree will split the data using the feature that provides the highest Gini gains. If you look at the graph section, you will see that the Gini value is highest value and will be added in the root. After running the final output, we visualize the decision tree using an image class that is to be imported from ipython.display package. You can see here. So the nice graph or visualized graph mentioned here. The petal width less or equal than 0.8. This is the highest Gini value, and then we have the 120 samples. The value are here, and the class of Virginica. Then they split it to true and false, and if true, the Gini value here is 0.0, and if the petal width less or equal to 1.7, again they will split until they reach to the root. For each root they classify the iris dataset. For more details, we have provided more technical example, and we will show you in next slide. Now it's time to describe random forest classifier. Random forest is a supervised learning algorithm. It is used for classification problems and regression problems. It creates decision tree on the given data samples, get prediction from each tree, and selects the best solution by means of voting ensemble. It is also a pretty good indicator of feature importance. Let's have a look to random forest algorithm intuition. Random forest algorithm intuition can be divided into two stages. The first stage, randomly select k features from a total of m features where k less than m. Among the k features, calculate the node D using the best split points. The next step is split the node into child node using the best split. Repeat 1 to 3 steps until a high number of nodes has been reached. Build forest by repeating step 1 to 4 or n number of times to create n number of trees. The second stage of random forest algorithm is to take the test features and use the rule of each randomly created decision tree to predict the outcome and store the predicted outcome. Then we calculate the vote for each predicted target. Finally, we consider the high voted predicted target as the final prediction from the random forest algorithm. The figure shows the random forest classifier. From the X dataset, we have n features, and for n features, you make different tree, and from the tree, you classify by the majority voting, and the final class will be available for you. I advise to double check the first stage and second stage. In a simple way, the whole process can be shown in this figure. First, we build some tree, then we define the label of data with voting methods. The advantages of random forest. Random forest algorithm can be used to solve both classification and regression problems. It is considered as very accurate and robust model. Random forest takes the advantages of all prediction made by the decision tree, which cancel out the biases, so it doesn't suffer from the overfitting problem. random forest classifier can handle the missing values. Also can be used for feature selection. On the other hand, the disadvantages of random forest are mentioned as below. The biggest disadvantages of random forest is its computational complexity. The model is difficult to interpret as compared to a decision tree, where we can easily make a prediction as compared to a decision tree. Now it's time to describe the random forest implementation in Python. The first step, importing the modules. In this case, the first and foremost setup in building our decision model is to import the necessary package and modules. We import the decision tree classifier class from the scikit-learn package. As I mentioned before, this is an inbuilt class where the entire decision tree algorithm is coded. In this program, we shall use the iris dataset, like the previous example, that can be imported from scikit-learn.dataset. The PyDot+ package is used for visualizing the decision tree. I will teach you how to install PyDot+ package for visualization. Okay, for the import library, we import some libraries and module that will explain during explaining the code. For the import the dataset, let's start up by loading a sample dataset. In this example, you will learn how to create a random forest classifier using the penguins dataset that is part of the Seaborn library. We import, you look at it, we import the Seaborn library as SNN in the first cell. The dataset provides information on 3 different species of penguins: the Adelie, Gentoo, and Chinstraps penguins, 3 different penguins. The dataset provides a number of data columns, some of which are numeric and others are categorical. Look at here. In the end, you will want to predict a penguin's species using the various features in the dataset. In this code, we also talk about some limitation of machine learning method. For example, they cannot work with the missing data and they cannot work with categorical or string data. Let me describe the dataset provided for penguins. This dataset provides information on 3 different species of penguins. As you can see here, we have Adelie, Gentoo, and Chinstrap. The dataset provides a number of data columns, some of which are numerical and others are categorical. In the end, you will want to predict the penguin's species using the various features in dataset. If you look at the feature from the dataset, we have the bill length and bill depth. Here is the bill length and bill depth. And also depends on their flipper. We want to classify the type of penguin. In conclusion, the body part of penguins is mentioned here. We have flipper, body, web feet, claws, belly, bill, eye and head. Now it's time to show our data set using data frame. By reviewing the information returned by the info method, you can see that both of these problems exist in the dataset. In order to be able to use this dataset for classification, you will first need to find way to deal with missing category and categorical dataset. This is exactly what you will learn in the next two sections of the lecture. Here, this is our data set. The data columns, total 7 columns. Here, column 1, 2, column 7. And some of them are categorical and some of them are numerical. Of course, we have some missing variable that we have to deal with missing data in scikit-learn. Now it's time to discuss about dealing with missing data in scikit-learn. While the info method tells us about non-null data, this can often be harder to interpret. Let's calculate the number of missing values in each column by chaining the isNull and .sum method. Here you look at this function isNull and .sum. Let's run it and you will see that in each column the total sum already calculated and how many missing value we have in each part. Again, I can show you in section .info from the data frame. When you have these columns as a feature, they counted the number of non-null data or sample. When you deal with .isNull and .sum, they will show you how many missing variable you have in each column. For example, bill length, you have 2 missing data. When dealing with missing values, you have two main options. The first option, impute the missing value. Imputing. The second option, drop the missing records. For example, either column-wise or row-wise. I don't recommend to do the drop of missing records. Sometimes it is valuable for you. For the most part, much of the data is there. Scikit-learn comes with the class simple imputer. We want to create the imputer that allows you to pass in a strategy to impute missing values. We can, for example, impute any missing value to be the mean of that column. Imputing categorical data can be a lot more complicated, especially when dealing with binary distribution. Because of this, we will drop any of the records where sex is missing. I want to show you how to create a simple imputer class, then fit the column to the object, then transform the data frame column with the fitted data. If you look at the previous total number of missing data, especially in column 6, you have 11 missing values. After applying the simple imputer and transforming the data frames column with the fitted data, and in another option, dropping missing record in the 6 column with the help of drop an A subset 6, you will find that 0 value. It means that there is no missing value in column 6. Now it's time to deal with categorical data in scikit-learn. Similar to dealing with missing values, machine learning model can be generally work with numerical data. Because of this, we need to convert our categorical data into numerical data. Let's deal with the sex variable first. Because the sex variable is binary, either male or female. We can assign the value of either 1 or 0 depending on the sex. This can be done easily with the map series method. You can see here the first step is mapping the sex variable to the binary value, because you want to change to the binary. Male is 0, female is 1. By this line, you can simply change it. From this data set, another variable is island. This is the categorical value. The island feature is the categorical value. Let's see what the unique value in this column are. See here, island. In the case of island feature, there are 3 values. Because of this, we cannot simply pass in a binary mapping. Similarly, passing in the value of 0, 1, 2 would also present problems, because the value don't actually imply a hierarchy. The difference between 0 and 2 would amplify any decision our random forest would make. If you look at to these 3 features which came from the island, a simple way to deal with this would be to use a process referred to as one-hot encoding. We call one-hot encoding. The unique values of that column are used to create columns where a value of either 0 or 1 is assigned. The image below, this image, shows the functionality of one-hot encoding. Finally, we drop unnecessary columns such as sex in this dataset. Here we want to show you how one-hot encoding works in Python scikit-learn, especially one-hot encoding the island feature. You added one-hot encoder, and in next section you put one-hot.fit transform in column island. After you run it, and you can simply drop some unnecessary column. Now it's time to split the data set into the training set and testing set. We created our features data frame X and our target series Y. Then data was split using training test split function. You already know about it. Let me run. Now it's time to create random forest model. You can use random forest classifier. We specified to create 100 different decision tree in our forest. You can see random forest, 100 decision tree. Now it's time to fit our data to the model by forest.fit, means that fitting a model and making prediction. We can do this using the employee name fit method, which takes the training features and label as inputs. From there, we can make prediction on our testing data using the .predict method by passing in the testing feature. Let's run. And now it's time to evaluate the performance of random forest. You have this formula, accuracy and accuracy score will predict your Y test 97%, and it's time to visualize your random forest. One of the difficulty that you may run into in your machine learning journey is the black box of machine learning, because libraries like scikit-learn make it so simple to create a random forest. It can be helpful to look at some of the details of your model. One way of doing this is by actually analyzing the patterns that the decision tree that make up the model look like. It may not be practical to look at all 100, but let's look at a few of them. The two images below shows how the random forest will predict your final result. Here is two images show the first estimator 0 here, the first estimator 0, 3, and the 12th estimator 10, 3. Here you can look at this random forest, how they success to predict these different classes.